Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12. Build your understanding, question number 10. The question is, a ring of radius r having a uniformly distributed charge q is fixed in a horizontal plane. A bead of mass m and an unknown charge stays in equilibrium at such point on the vertical axis of the ring that if it is displaced slightly up or down, it undergoes oscillatory motion. So find charge on the bead. Intensity of gravitational field is to be taken as small g. Let us solve this question. We have collected all the data over here, that ring of radius r and having a charge q uniformly distributed over it, fixed on a horizontal plane, a bead of mass m but unknown charge on it, bead stays in equilibrium at such point on the vertical axis of the ring that if slightly displaced up or down, it undergoes oscillatory motion, means this condition is given. Intensity of the gravitational field to be taken as small g. So charge on the bead will be what? Since the bead is in equilibrium, hence the net force on the bead should be 0. So net, which all forces acting on bead is gravitational force mg and force due to the ring on the bead. This is electrostatic force. Since gravitational force is acting down, the net force to be 0, it becomes important that FBR should be vertically upward to cancel out mg. It means the bead should have the same charge, but same kind of charge which is there on the ring. If capital Q which is on the ring is positive, then on the bead small q should also be positive. Let us say the bead is y distance away or above the center of the ring O. The electrostatic force on the bead due to the ring that we have notated as FBR, F subscript BR. B stands for bead and R stands for ring. So this one can be read as force on the bead due to the ring. At y distance above, we can write this equation. The force due to gravity is mg, which is already, Now we have one more information that, or we know that maximum electrostatic force in such kind of arrangement will be at r divided by √2 distance above the center, because E field is maximum. E field intensity is maximum at this distance above the center of the ring. It means below this distance, the electrostatic force will decrease. And above this distance, it will also decrease. So the gravitational pull is constant throughout. So the bead to oscillate, it becomes essential that the bead should be located above the r by √2 distance, and mg should be less than electrostatic force, maximum electrostatic force that will act at y is equal to r by √2. So what will be the maximum electrostatic force on the bead in this arrangement? We will put y is equal to r by root 2 and we will solve it for. So we can get this 2k capital Q small q 3 root 3 r square. And the second condition that mg should be less than FBR R max, we will put the value of FBR R max. And from here, we will get this expression. Q should be greater than 6 root 3 pi epsilon naught mg r square on numerator and in denominator Q. It's important to understand why this condition is important. Because suppose if mg is greater than FBR max, so what will happen when you shift the bead above r by root 2 and leave it, mg being bigger than FBR max, it will pull down the bead and it will further go down. Being greater than FBR max, it will further go down, 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 down. Because after r by root 2, the force on the bead will start decreasing from its maximum value, that is FBR max. So it will keep going down, so it will not oscillate. So that is the reason we have taken this condition. I hope you understood the concept. In case of any doubt, please do write in the comment box. I will clarify the doubt. Thank you.